You can build your own AI agents. Yes, you can. And it's far simpler than you imagine. In this video, I'll walk you through the entire process step by step, so that by the end of it, not only you will understand what AI agents are, but you will actually build one yourself. So let's get started. You've heard about AI agents, right? There's a lot of buzz surrounding them. With everyone talking about it, a lot of jargon gets thrown around, and the aim of this video is to simplify all of that and break the concept of AI agent to its bare bones. Ultimately, by the end of this video, it is to enable you to build an AI agent of your own. Let's first understand what AI agents exactly are. So, this is what we would be covering in this session to make that happen. First, we'll break down what are AI agents, then we'll move on to exploring existing AI agents so you can see some real-world examples that are already out there. After that, we'll dive deep into the core components of AI agents, and we'll also spend some time understanding AI workflows, which are closely related but have some key differences. And then comes the super exciting part, where we would be building our own AI agent which would act as a Google Calendar assistant. Finally, we'll wrap up by comparing AI workflows versus AI agent, which would help you decide what's the best approach for different tasks. The field of AI agent is relatively new, and it's not yet definitively defined with many vague interpretation and variation. However, the definition I like the most is the Google one. They state an AI agent is a system that once given a task or a goal, achieves the outcome of that task completely autonomously without any human involvement. This is a pretty broad definition, so let's unpack it a bit. First, start with an example. Let's say you have to book a travel vacation to Bali. As a human, how would you go about it? You would start by opening your preferred booking app. You would search for flights, you would search for hotels. Then one by one, you would figure out which options fit your budget. And finally, you would lock in your choices and start booking them. This whole process would take a lot of time. Now, what if instead you had a human assistant with you? You would tell them your budget and the kind of places you want to see. They would handle everything for you and provide the final bookings. So this is what AI agents can do. And this is what we mean when we say they achieve their goal autonomously. You take an AI agent, give it a goal, and it would autonomously take all the necessary steps until your vacation bookings are done. Booking travel is just one example. An AI agent could, for instance, build an entire website for the business. You would simply tell what your business does and what features you need on the website. And it would start from scratch, and in the end, you would have a website ready to share with your customers and your potential clients. So there are numerous AI agents that already exist, and there might be new type of AI agents emerging in future as well. The promise of all these AI agents is that any task that can be done end-to-end on a digital computer can be achieved through an AI agent. The impact of this is immense. Consider how many tasks in the current economy that can be done end-to-end on your computer. For example, a majority of software engineering tasks can be done end-to-end on your computer. Also, video editing can be done end-to-end on your computer. Tasks related to accounting and many more tasks can be done end-to-end on your computer. So let's say if we were able to create an agent for all these aspects, capable of performing tasks autonomously, given a goal, it would reduce human effort to a great extent. Now, we'll take a look at where we are currently. First, let's start with coding agents. So, coding agents are type of agents that would autonomously build a website for you. For example, we have Lovable. So you give it a prompt and it would build you end-to-end website that you can share with your potential customers and clients. So let's take a look at it. So here you can visit this URL and you can type in a prompt and it would create a website something like this, and that you can share with your customers and clients. Now let's take a look at different type of agent. This one is called browser use. So what it does is it gives the agent control of your computer, and the agent has all the means to act on your behalf. So let's say you give it a task, let's say to find jobs that are relevant to you within 2 years of experience and that are of data analysis. So the agent would open all the relevant website, gather all the job links, and in the end would give you a comprehensive list of the jobs that you can apply to. Now let's take a look at how browser use works practically. So here I have the GitHub link. It's an open source agent, and as you can see, you can install it on your own and you would be able to use this agent on your own computer. Let's take a look at example here. So the example is, the task that you have given here is to add grocery items to your particular shopping cart. And what the agent is doing here is, one by one, it's picking up the items and it's adding to the cart until all the grocery items are added. So this is how browser use is working for this particular task. And the concept is the same. You give it a goal and it would act on your behalf on your computer, and it would do that till the goal is achieved. So these are two kind of agents, and we have many more currently. So before we start building agents, let's quickly understand what an LLM is. So LLMs are nothing but large language model. And a large language model is essentially a program that you give text as an input and you get a text as an output. And the text that you give as an input, it processes it and it gives you the output text. And the way these large language model processes the text is based on how they are trained. And essentially all these models are trained on enormous amount of data, almost the entire web. When you train them on so much data, they start to learn patterns. And because of this ability, they develop so many capabilities that are useful to us. For example, if you have a math problem you are stuck on and it's not too tough, you can give it to an LLM as a text and you would get the solution to that problem as the output text. Or let's say you have a very big article, 2-3 pages long, and you want the summary of that article. So you would give that article to an LLM as the input text and ask it to summarize it. And you would get the summary or TLDR of that article as the output text from the LLM. So these are just two capabilities that we discussed. There are literally n number of capabilities that these LLMs develop. The overall aim is to understand how these LLMs work and how they fit into overall agentic system. So let's quickly try out an existing LLM. Most probably you have heard of it, it's ChatGPT. So we'll try out ChatGPT itself such that we try to understand what exactly is happening under the hood. Okay. So I've given it a prompt. It's how many different walls are there in strawberry. So I gave it this input text and I got out the output text. Now this is what ChatGPT has done based on how it's trained on, right? The output in this case is correct, but we'll take a look at it in the future sections. What are the limitations and how we can address them? So let's take a look at another example, a bit more complex this time. So let's say we give it a JEE Mains question as an input text and let's see if it's able to answer it correctly. So let's try to find out a recent question and we'll pass that to ChatGPT. And let's see if we are able to get the correct answer. So we can see GPT has started answering. It is first defining the variables of the question, and then it's breaking out the problem in small steps and trying to solve those steps one by one. So we got the first step, we got the second step, and eventually it's giving us the final answer. That's 15 by 32, which is incorrect. That actual answer is 13 by 32. Let's do one thing. Let's try it one more time. Let's try to give the same question again and see if this time it's able to answer it correctly or not. So again, it follows the same process. It first defines the variable of the question. It breaks down the problem in multiple steps. And one by one, it's trying to solve the individual steps. So you got the step 1, we got the step 2, we got the step 3. And eventually, we'll get the answer in this step, most probably. Yeah, so we still got 15 by 32, which is an incorrect answer. So we can see this question is a bit tough for GPT. Let's try one more question and see if you are able to get the correct answer for that particular case. So we'll pick this. We'll give this input text again. Again, the same process. It first defines the question variables. It tries to break down the problem if that's possible. And then step by step, it tries to arrive at the final solution. Yeah, so we got the answer as 0.25. That is not matching with the answer of 4. So what we can see here is that it's actually the inverse of that. So let's do one thing. Let's try to pass in the options as well, so that it has the full context of the question. And then let's see if it's able to arrive at the correct solution. Yeah, so we got the answer as 4. And as we can see, the correct answer is 4 as well. So what we saw just now is, we gave it one question that it was not able to solve. And then we gave it another question that it was able to solve. So we know it's not up to the level of solving every question, but it's already at the level of solving some of the question of the most recent JEE main paper. One thing I need to mention that is, it's not just related to text now. The current LLMs can take image and even audio as input and can output text, image or audio as output. So this is a very recent development. So some of the older LLMs might not be able to do this, but most of the current LLMs that are coming out can take text, image or audio as input and can output text, image and audio as output. So now that we have understood what LLMs are, let's quickly take a look at what their limitations are. So I've given it a prompt, what is greater 10.11 or 10.9? So the output that it has given me is 10.11 is greater than 10.9, and it has also given me a false explanation for that. So this particular limitation is called hallucinations, where we just saw that this particular LLM was able to solve a JEE mains question, but it failed at this second or third level algebra question. Now, hallucinations are a very long-term problem with LLMs. We don't have an immediate solution for them, but there are certain strategies that we can have that helps us in controlling and limiting this particular limitation. So one is hallucination. What's next? Another is knowledge cutoff. So LLMs are trained up to a certain point in time on the data that was produced up to that particular point. So let's say if I ask ChatGPT, who won yesterday's IPL match, it won't be able to answer that. So let's quickly check that out. So I have given this a prompt, who won yesterday's IPL match, and the output that I have got is, I don't have access to real-time information. So this is the limitation of knowledge cutoff. It does not know what has happened after the date till it was trained on. So any query that is based on the knowledge of the data that is created after its training date, it does not know how to answer that. So one limitation is hallucination. Another one is knowledge cutoff. What's the third one? So if you see, these systems, they are text in and text out systems. While they are very powerful, their utility becomes very constrained because of their inability to act in real world. They can't take actions on their behalf. So if I wanted a real assistant, I could have asked that particular assistant, let's say my task is to plan my next day and update my calendar. So that human assistant, how would it go about it? So it would look to my Google Calendar, it would update the relevant details, and it would say back to me that the task is done. But this particular thing, LLMs can't do because they can't connect with the external systems. So we have a text in and we have a text out, but this text out does not do anything. They can't act in the external world. So this is the third limitation of LLM. So these are the current 3 limitations of state-of-the-art LLMs. So there are no direct solutions for them, but we'll see how agents addresses some of them. So just to summarize, what we have learned till now is, we understood what AI agents are, what is the definition, and then we looked at few practical AI agents like Lovable and browser use. Once we understood that, we took a slight detour and we understood what LLMs are and what is happening under the hood. And then we understood what are their capabilities and limitations. So let's quickly check out one other thing that is called prompting. Most probably you have heard of this as well. So what prompting is it's just the input text that we give to LLM. So whatever is the input text, that counts as the prompt, and whatever is the output text, that's a response from the LLM. Now we have another term called prompt engineering. So the concept of prompt engineering is pretty simple. So we just saw that LLM failed on a very simple problem and excelled on a very hard problem. So how do you tackle that? So you engineer at prompt level. So you make sure that the prompt you write is in such a way that the chances of success become very high. So what we wrote was, what is greater, 10.11 or 10.9? So let's change it a bit and let's see if you are able to get to the correct solution. So what we have here is the same prompt as earlier. What is greater than 10.1 or 10.9? What we have done is we have added one more phrase to it, that is, let's think step by step. And the output of that is now, it's one by one breaking the problem down, and eventually it's able to give us the right solution. So it won't work every time, but this particular thing helps us in getting the right answer more number of times. So this is one example of prompt engineering, and this particular thing is called chain of thought prompting. We won't go into details of how many different types of prompting are there, but if you want, there is this really cool website that you can refer to. It's called Prompting Guide. So here you can see we have different types of prompting. We have zero shot, we have few shot, and a chain of thought that we just took a look at. So zero shot is nothing but where you just give the objective of the prompt without any examples. And in few shot, you give the objective along with few examples so that there is a better chance of getting to the correct solution. So if you want to explore more such prompting techniques, you can take a look at this particular website and you can do that on your own time. We won't go into the detail for now, but just so that you know how many different types of prompting techniques are there, you can refer this. This concludes our LLM section. So up to this part, I think we have developed a good understanding of what LLMs are and how to work with them. Now in the next section, we'll be majorly looking at how we address one major limitation of LLMs. And then we'll arrive at what are agents. So let's address this one particular limitation, that is that LLMs can't act in the real world. So how do we make sure that these LLMs have the capability of interacting with already existing softwares? So before that, let's first try to understand how existing software communicate with each other. So they do so through a thing called APIs. APIs are application programming interfaces. So if one software want to communicate with another software, they would do through APIs. So let's say if I wanted to communicate with Google, what would I do? I would ask Google, this is what I want to search. Google would execute that request for me and share the results back to me. So in the API world, how would that happen? So my software would send a request to the Google server. It would ask, can you please execute this? Google would complete that request and share the response back to me. So this is how the flow goes. You have the request, you send it to the external server processes it and shares the response back to you. So this is how briefly how APIs work. So we won't go into details of how many different types of APIs are there, as our primary goal is to understand how to connect LLMs with external systems. So they do so by the means of tools. So tools are the means where LLMs connect with external systems. As of now, there are different kind of tools. All of these tools you can assume as a program in your computer. They take a very fixed kind of input, they processes them, and then they give back the output to you. So these tools are integrated with LLMs, and that gives them the ability to interact with particular external systems. So how this tool call would go is, the LLM would raise a requirement. Let's say if it wants to search Google. So you would send a search query to Google. That search query would be executed by Google server. The Google server would give back the output to you. And then the LLM would process that output. And then eventually it would give the result back to you. So this is the tool call for Google tool, let's say. Now there are n number of tools that are available that you can integrate with LLMs. And that gives them different capabilities to interact with different kind of external systems. Now let's quickly take a look at what other components of an AI agents are. What we have learned till now is what are LLMs and what are tools. Now let's take a look at the third component, that is called agentic loops. So the core value prop of agentic loop is that how do you go about reasoning about the task and go in a loop till the goal is achieved. So what you do is you look at the environment, check the state, take in a particular action, the environment updates, then you give the feedback, you take the action again, you get the feedback, you take the action again, and you go in this particular loop till you feel like the goal is achieved. So this is what agentic loop is. The last component is memory. So we know LLM is the brain, right? But the LLM does not remember anything on its own. You send in some text, you get out some text. But now, the next time when you send in some text, it does not know about the text that you sent in the first time. So in this particular case, we have to make sure that it knows what has happened in the past, and that component is handled by memory. In ideal scenarios, memory is nothing but the previous chunk of text that was sent in along with the responses of LLM for those particular text. So you stuff in all those things that has happened in the past, and then you give it the new objective, the new prompt. So this is the role of memory. So let's quickly take a look back at all the different components of AI agent that we have learned till now. So first is LLMs. Second is tools. Third is agentic loop. And fourth is memory. The most critical one out of all of this is the LLM. But in practical scenario, when you are creating these AI agents, all the rest of the component become equally important. And we'll come back to it later at how and what things we need to keep in mind while integrating or working with each of the components. This completes the components of AI agent section. Now quickly, we'll take a look at another term called AI workflows. We looked at AI agents, right? We also know another limitation of LLM, that is hallucination. So LLMs are not perfect. And if you were to give the task of taking decisions to LLM, it is error prone. If we have a certain error percentage in a particular task, the reliability of that task goes down. So in those particular scenario, we have another AI system that we can use that is called AI workflow. In a workflow, you predefine the path the task has to take. So you strip away the complexity of LLM deciding what to do next. Instead of that, you define the path that should happen. And one by one, each of the step is executed. So in this particular scenario, you are increasing the reliability of the task and at the same time you are decreasing the complexity. So AI workflows can handle tasks much more reliably as the task is already broken down into multiple subtasks compared to AI agents, where you don't break the task into multiple subtasks. Instead, you give the appropriate tools to the agent and let the agent decide what to do next. But at least as of now, AI agents are not that reliable and they can sometimes go wrong in executing your particular task. So it's always better to stick to AI workflows where you are predominantly concerned about reliability and you have a way to break that problem down into multiple subtasks. Let's get started with building our own AI agent for Google Calendar Assistance using N8N. Just so you know, there are other platforms you could explore as well, like Mig.com, Zapier, and Workato. Here's how we are going to go about it. We'll begin by creating an account on N8N and obtaining an API key for Gemini. Then we'll start by building the agent without connecting any tools. Once that's in place, we'll bring in Google Calendar tools so that agent can start performing actions on your calendar on your behalf. Go to this particular website. You need to log in, okay? So you give in your credentials, okay? So your full name, once you're done with this, you can just quickly fill out this survey and you would be redirected to N8N dashboard, okay? Meanwhile, this is happening. We'll quickly get a API key. So we understood what a API is, but API key in general is simply, let's say, I wanted to contact Google server. Okay. Now, Google would be doing processing on my behalf, right? For me. So they won't do it for free. And they don't want to do it for everyone without verifying them. So to do that, they add a API key layer where you have to give the key along with your request, so that firstly they know who is making that request, and secondly they also know that do you have enough balance in your account to process that particular request. Okay, so we need an API key for our LLM. So all these LLMs, when you're using on their website, most of them have a pretty lenient free trial. But when you are using them programmatically, you need an API key for them. So for now, we will be using Gemini because it has a pretty decent free tier on API as well. So you can just open AI Studio and you can click on Get API Key. Select any of the project. And you can just copy and keep a track of it somewhere. Okay, so yeah, so we got the API key for RLM. Now let's go back to N8N. So we signed up on N8N, we got our workspace link, and this is our N8N dashboard. Okay, now once you are here, you would see projects. Okay, so we would go with the default project and we would click on create workflow. So make sure that you know this is for both agents and workflows. When you're clicking on create workflow, you can actually create an agent as well as an workflow. Okay, now once you're here, so if you click here, first we need the trigger point. So when should our agent be triggered? So let's for now let's create a chat agent. So whenever user sends a message, that's when the agent should be triggered. Okay, wait. So on chat message we would select, and we don't need to change anything in options. Go back to canvas. So you are on chat message. Now we'll select AI. We'll select the AI agent. And for now, we won't make any changes. We'll come back to it. Let's select the model. So chat model is simply which LLM we want our agent to use. Okay, so as we have got the API key for Gemini, we'll select Gemini. We'll click on credentials and we'll paste in the API key that we have got. Yeah, so and we'll also select the model. So for now we'll select the latest model, that is Gemini 2.5 Pro, the May version. And now our agent is configured. Now in terms of memory, so we want a very simple memory. Just so you know, there are one way to store memories. Just send in all the past interactions back to LLM at every iteration. Okay, another way of adding memories, that is a long-term memory. So you keep a list of all the things that you have have happened in past, okay? And instead of sending everything, you send the most recent ones along with all the things that are relevant from the not recent ones. So this is another way. This is a bit complex. We won't go into that. For now, we will use the most simple memory, okay? And we can select how many previous iterations should be sent back at every iteration as a memory. So we can select 15 here, okay? Now, once we have got to this point, we haven't added any tools. We'll just quickly test out how is it working, okay? So we'll open the chat here. We'll type in some message. Okay, so what would this do is, this message would be first stored in memory, and then based on the current state of the memory, it would be sent to the model. So this is the memory, and you will get a reply from the agent soon. Okay, let's do one thing. As we are using this model, this is taking a bit of time. We'll quickly change the model instead. So using this, let's use a simpler, less complex and faster model. Okay, so we'll use let's use this. Let's come back. Let's so let's look back what we have done. We simply changed the model to a less complex one so that we get the results faster, as we are still in the development mode. Okay, so we connected our LLM, we connected the memory, we have the agentic loop set up. What is next? Tools. So for this particular LLM, or for this particular agent, what we really want to build is an agent that helps us in managing our Google Calendar. Okay, so the tools we would be needing should also be of Google Calendar. We would be adding tools now, and we have tested that everything else is working fine till now. Okay, so in the next section we would add the tools, and then we'll see if our overall agent is working out fine. Okay, so we have looked at how to add the chat model and the simple memory till now. Let's start adding the tool for Google Calendar as well. Okay, so you can go here, click on plus, just a sec, move it a bit down, we can click on plus here, and then we can search for calendar tool. Okay, so we see this Google Calendar tool. What we want is, we want a tool description. So when to use which tool and what that tool does, you can either write it yourself, like using SAT manually, or you can get it directly, whatever is the default one, or you can ask the LLM to know it. Okay, here we would choose set automatically. We would use event. We would be majorly dealing with events for now, and let's create tool for creating an event in calendar. Okay, I'll choose my email ID. Start time, end time of the event, let's get as input from model. We'll add fields for summary. Summary is nothing but the title of the event and the description of the event. Okay, yeah, so once we have configured our event, here just one more point that I've missed, that when you're creating, you need to connect to the Google Calendar account. So in my case, it was connected by default, but in some cases, you need to just allow permission of Google Calendar from your Gmail account. Okay. So once we have done this, let's move back to chat and let's ask it to create. And for lunch, at 1 to 2 p.m. on 9th May. Okay. Now, I think, okay, we have got a reply. The reply is that it's asking for description. And it's also asking if this date time is correct, which is correct. Okay, so it's saying okay, I've created the event. Let's quickly check it. So for tomorrow, we have got an event for lunch. Yeah, 1 to 2 p.m. Not tomorrow, on 9th May. Yeah. So this worked out fine, right? Now let's do a bigger task. So I generated my so I've given my schedule here and I've asked it to update this in my calendar for 9th May 2025 one by one. Okay, let's see. Okay, so we see the error now. It's trying to make all the tool calls simultaneously and that's not working out. So let's do one thing. Let's create a new chat. Okay, so you can see here, so it's using one create tool at a time now. So first it's answering back one tool call, answering back one tool call, and so on. Let's see if yes, so this is also getting updated. Yeah, right. Now ideally the thing that we have added here, that can you update this in my calendar, and then we need to add this use one create tool at a time, right? It's not a task like this thing specific instruction, right? This is a in general instruction to the agent. So this we write in the agent prompt itself so that it is being sent in every call to the LLM. Okay, so we can configure our agent here. And we can add the prompt here. Right, let's go back. Before that, let's also add one more tool, which is to delete events. Okay, so if we go here, we already have a create, we would add the delete. We'll choose my calendar itself. Okay, so we have added the delete event. Now, for delete event to work properly, it should also know which events are there, right? So for that, we'll also add a get event tool, like which events are already there. Okay, cool. Okay, it's showing some error. Let's see. Yeah, we forgot to select a calendar. Yeah, we have configured it now. So we have three tools now. One is getting which events we have. One is to create the events, and one is to delete the events. Now let's check a session. First thing, let's do one thing. Let's ask what all events I have for 9th May 2025. Okay, so it's asking to start and end date time. Yeah, so we can just confirm, should we consider beginning and end of the day? Yeah. Cool, let's see now. So it made one tool call, which is Google Calendar 2. That is nothing but get all event, and this is the exact events that we have, right? Yeah, so we have looked at how can we create a calendar tool, and then we created three tools: Google Calendar for deleting an event, creating, and getting all the events. Okay, now once we've done that, so what we want to do now is we have all these events here, right? So we want to delete all of them. Now to do that, what we can do, we can simply make a request here, delete all the events for 9th May 2025. Okay, and ideally it should first check what events are there on 9th May 2025. Okay, there is some issue. Let's try again. Yeah. Yeah, so ideally first it should be checking which events are there on 9th May 2025, and once it gets to know that, then one by one it should start deleting those events, right? So ideally first it should be checking which events are there on 9th May 2025, and once it gets to know that, then one by one it should start deleting those events, right? So, okay, this is a weaker model. So it asks me, can you share me the event IDs? Uh, Ideally, you can ask it back to get it on its own. Yep. So it deleted the event, and let's see, they are gone. Yeah. So basically it first listed down the event, okay, and then one by one it deleted all of them. So one tool call for getting events before on basically 9th May, and once it got that, then it deleted all based on the event IDs. Okay, so this was pretty straightforward. Now, why one change that we did earlier, right? That we asked it to, like we added an instruction, call one tool at a time instead of calling all the tools in a single iteration. So let's see now, do we need to add that here? And if that is not needed, that means that instruction is working fine. Okay, so it made one tool call, and let's see if it's done. It's done, right? So we have essentially created this agent that can do all the Google Calendar stuff for us. Okay, like if I ask it to, can you check if I have, let's create a new chat and let's see, anything on 9th May 2025. Check and hold day. Okay, so it correctly shows me that first is work and second is lunch. Okay, so if I ask it to please delete, please change work from 2 to 3 to, okay, instead of that let's ask it to please delete work, instead add 3 to 4 play. Okay, okay, again one common instruction. Okay, it incorrectly says that there is no event. Let's ask it again. Yes, so I deleted that. Let's quickly check it. It's gone, and now it shows us, do you want me to add the play event? Yes, and yeah, it has created that, and we got the play event, right? So we have created this agent that essentially controls all the calendar for us. Here you have uh, creating an event, deleting and getting which events you have today. All those things you can do it through this particular agent, right? So now, till now, basically what we have done here is that we have looked at how to create the agent, okay, using a no-code tool, how to configure tools in it, how to add memory to it, how to add instructions, and when are instructions needed and what kind of instructions are needed. So just like we saw here, instructions are all the common things that we need for the agent, we can add it here. So one more instruction that we can add here is that you don't need to ask for event IDs, you can search for it using the get tool, right? That particular instruction would help us in reducing a bit more of human involvement, okay? So here, this concludes our agent creation using N8N section. Now we'll quickly look back and see what are the things that practically we need to keep in mind when we are creating these agents, okay? So first thing is reliability. We just saw that few times it makes the claims that are not actually true. Like when I asked it that please delete work, okay, it said there is no event like work, but that is not true, right? And if I didn't cross check with my calendar, I would have assumed, okay, maybe there is no such event, and I would have carry forward with that. But for the tasks that are very critical, this can't work, right? For those particular tasks, we need to add guardrails so that either we capture this reliability issue, right? Or basically we make sure that in those particular tasks we have a slightly more uh, reliable approach than just simply using agents. So what that more reliable approach would look like? So that would look like a combination of both workflows and the agents. So in ideal world, you need agents where you can't have workflows. And if you have workflows, just simply use workflows, because workflows in general would be more reliable to achieve any task, at least as of now, with the current state of models that we have. And if you can't do it with workflow, change only the parts that are really needed to agents and keep rest still as workflow. So in this particular task, let's say, so if I would have been using it to simply plan my day and upload it to Google Calendar, then I could have kept that as a simple workflow of adding, sharing my basically my schedule to the LLM, and then that schedule is converted to an tool call, and then that tool call uploads my LLM my schedule to the calendar. So that workflow could have been created for one simple task. But let's say for this particular use case where I don't have a very specific task, it's all kind of tasks that involve Google Calendar, then I need an agent. So it's a trade-off between the complexity of the task and the reliability of the task. So if you reduce the complexity and you are trying to come at a task that is a bit less complex, then you can make it work with workflow directly. But if you maintain the complexity, then you would be needing to use agent. But as of now, agents are less reliable. So the more would be complexity, the lesser would be the reliability. So this is one point. So first point is make sure that reliability is like at least try out your model multiple times to ensure that it's highly reliable, and try to add as much guardrails, as much scaffolding to it, so that whenever it's not reliable, you catch it, or you do enough experimentation to know what all failure modes are there, right? So first is reliability, second is choosing between workflow and the agents. And third is observation and then iteration. So right now here we saw that first time it was making multiple tool calls at the single iterations. That is incorrect. So we quickly fixed that by adding a common instruction to the agent itself. Now, if we do that, that is one failure that we have prevented in the future cases. If we add more, if we do more iterations, we would come up with more failure modes, and we can reduce those failure modes either by updating the agent description or by adding a detailed description of every tool, or by simply upgrading to a model that is smarter. So right now we are using Gemini Flash model 2.0 Flash that is not that smart compared to the recent models that we have, but it's faster, right? So if we were to use a better model, our agent would have been slow, but our overall accuracy and the reliability of the task would have been higher, right? So that is one thing. And finally, the tools that you are choosing, right now we haven't given any manual description to tools, but when you are using this into some production systems or inside your company, these agents, so make sure to write detailed description of your tools on your own so that you cover all the things that are required for that particular tool, okay? Like why that particular tool is used, when to use that tool, and all those stuff. These are some general best practices that we should be following while creating the agent. And apart from this, always try to see like the go-to method for you in such situations should be observe and iterate simply, because all these systems are inherently empirical. Like there is no general solutions that fits. So always try to make sure and observe what kind of failures are happening, and then see how you can eliminate those failures by changing what part of your system. Okay. Now to conclude, in this particular session, we have learned what are AI agents. We have learned for a particular AI agent what are the components, and then we have learned about what all components are there, what are LLMs, what are tools, what is memory, what is agentic loop, and then we move forward to first compare the difference between AI workflows and the AI agents, and then we built an AI agent for Google Calendar using N8N, and then we looked at what are the best practices for creating AI agents. Hope you have picked something valuable today and are excited about building your own AI agents. The best way to truly learn is by doing. So get your hands dirty, pick a use case, and start building. If you have found this video helpful, make sure to subscribe and click the bell icon so you don't miss out on more such deep dive content. We have a lot more coming your way. See you in the next one.